have another box. So if we wanted to wrap this up with wrapping paper and we wanted to figure out the surface area of the box, there are two different ways you could go about this. One, you could imagine all of the sides. Okay? One of the sides is right here. I'm going to draw this side here in blue, and I'm going to color it in blue using crayon because I love coloring with crayons. So I just drew that side in blue, and I colored it in with crayon in blue so that you could see that side. And if we said, what are the length and the width of that blue box based on the picture above, it would be what by what? Yeah?
It says bottom. If you scroll down, I guess, it says bottom, and I'm looking at that, and I'm just wondering if you could define the bottom of the box. Could you just do the side panel times 2?
Okay. Well, right now we're not looking at the solution. We're just talking about the box and coming up with a way that we could do it.
Okay.
You can read the solution after there, but if I'm figuring this out, this is one way that I could do it. And it's similar to solution 1, but I've got a side there. What are the dimensions of this side? The bottom, this length here would be 40, and this length here would be 20. So we could say that the area of this whole thing is going to be 40 times 20, which is 800 centimeters squared. Can you see that you would have two of those? You'd have this one on one side and the same on the other side. Then if we go here and look at this box, and I draw it here in green, I'll color that in with green crayon. What are the dimensions of that green square? 30 by 20. If you multiply those together, you're going to get 600 centimeters squared. And if you do that one there, you can see that there's another one of those at the back. There'd be two of those. And finally, what haven't we covered? We haven't covered the top and the bottom. So if we get out red wrapping paper for that, it's another rectangle. So we could color that one in. Oh, I'm good at coloring. And what are the dimensions in red of the red one? They would be 30 by 40. Multiply those together, and we get an area of 1,200 centimeters squared. And we have two of those because we have the top and the bottom. So if you were wondering how much paper you would need to cover it, well, you'd have to use 2 pieces of red wrapping paper, 2 pieces of green wrapping paper, 2 pieces of blue wrapping paper, and we could calculate the total surface area of this by adding those up. 2 times 800 would give us 1,600, plus 2 times 600 in the green would give us 1,200, plus 2 times the 1,200 would give us 2,400 for the red. Add all of those up together, and we get a final answer of 5,200 centimeters squared. So in your solution that they provide, they do a similar thing, but they draw the net. They open it all up as a net and say, there's our bottom, there's our top, they're the same. There's our sides and our end panels, they're the same. And if we do all of those things up together, we get the same numbers of the 1,200, 2,400, and 1,600 to add them up to get 5,200. So this is both solution 1 and what we did here is the idea of imagining all of the shapes that you have, and then you just have to add up those shapes to get your surface area. Now you do have a formula sheet, so solution 2 says, well, if I look at my formula sheet, and I'm going to go directly from our formula sheet says 2WH plus 2LW plus 2LH. And if we look at our picture, we have to decide which one's going to be which. Most people will say that this here is your height. Your length and your width depends on how you look at it. Some people always make their length longer than their width. So then you would say this is your length, this is your width. It really doesn't matter which one you say is your length and which one you say is your width. It's going to work for your formula either way. So if we take those numbers, and we got 20, 30, and 40, and now plug them into our formula, right? Our width was 30, our height was 20. Our length was 40, our width was 30. Our length is 40, our height is 20. And you can either figure these things out individually, or if your calculator is good enough, you can go 2 times 30 times 20 plus 2 times 40 times 30 plus 2 times 40 times 20, push equals, and your calculator will tell you the answer is 5,200 centimeters squared. So here's one for you to try. We'll put the answer up in a second. Now it's in feet. Figure out the surface area. You can either draw out the different rectangles or use your formula. Decide which way you would like to go, either to draw out the different rectangles you would need or to use your formula to figure out this surface area. All right, so if you used the strategy of thinking of the shapes, okay, we have a shape here. It's a rectangle. Color that in blue. That rectangle has 3 feet along this side, and since it's 2 feet high over there, it will be 2 feet high over here. Now you have that rectangle here in the front and also in the back, so you have 2 of these rectangles. If it's 3 feet by 2 feet, the area of this one will be 6 feet squared, and you'll have 2 of them, which will come to 12. If we're going to figure out our total surface area in the end, we have 2 of those. Next, I think about this side, this rectangle. If I color that in, I'm going to have 2 of those that are now 4 feet and 2 feet high. I better color that in, you're right. And the area of this one is 8 feet squared, and we have 2 of those because there's one on the side here and one on the other side. So now we've counted up 4 sides. That makes 16. So we're going to add 16 to our total surface area. What we haven't counted is the top and bottom side, you're right.
6 sides and a cube.
And so I'll color that one in red. Okay. If I draw that red one, if we look at our picture for our top and bottom, well, it's going to be 4 feet here and 3 feet here for a total of 12 feet squared. And again, we have top and bottom, so we have 2 of those. Added up will be another 24. So if we want to figure out the total surface area, we add all of these up, and it's equal to 52 feet squared. So that's using the shapes. Some of you, how many people use the formula? Okay, so using the formula, your formula says, and I'll write it in the exact same order that we have on our formula sheet, 2WH plus 2LW plus 2LH. So again, I would go to my picture if I'm using the formula. When I'm showing my work, I always write out my formula. Then I go to my diagram and I decide this is going to be my height, this is going to be my length, this is going to be my width, so that when I'm showing my work, I know which numbers to plug in, Because I can look at my diagram. Which one was W? Oh, it was 3. Which one was H? It's 2. Because sometimes if you don't do that, you might end up putting the same number in the wrong place twice or making a simple mistake like that. The length is 4. And when we plug in numbers, it's good to plug them in brackets. Now this means 2 times 3 times 2 plus 2 times 4 times 3 plus 2 times 4 times 2. Type that all into your calculator at once and you'll get the answer, 52. Since we're dealing in feet, we'd add our units and its area, so it'll be feet squared. If you don't have a calculator that lets you plug in everything at once, then you might take an extra step, I'll write it in black here, and do 2 times 3 times 2 and get 12. And do 2 times 4 times 3 and get 24. And do 2 times 4 times 2 and get 16. Notice these numbers in black sure match these other ones that we did in method number 1. And that's why the formula works, and that's why we get the same answer.